Every year, billions of birds migrate. Their journeys are filled with uncertainty. Many don't make it, and some don't make it back. This is a story about uncertainty. All stories have elements of uncertainty, of course. Does the hero get what they want? Can they save the world? Will they or won't they? You know the drift. We spend our lives trying to remove the from uncertainty. What if instead we let it in? Welcome to Helgoland, an island in the North Sea. It's not down on any map. At least, not one that a bird could use. They have other means of finding their way. Do you feel it? The migratory restlessness. It's an overwhelming feeling, a need, really, as urgent as breath. To leave. To fly. But where? Such a small creature for a journey so far. How will you find your way from Spain to Scandinavia in the north? With light, you can navigate using the stars. Like an ancient sailor, you've studied their movements since you could first see. And during the day, a brighter light perhaps. You can read the sun's position like a book. But what if these lights are dim to you? What if they are hidden by cloud and storm? How then will you find your way, small traveler? I wish we were a bit closer. You might wonder why I'm all the way over here instead of right in front of you. But of course, you had a hand in this as well. This is where you observed me, all the way over here, so far away. I'm sorry, I shouldn't complain. Quite frankly, that was a close call back there. I'm lucky you observed me so close to shore. Thank you. I guess I'm the narrator of this outfit. Welcome to Helgoland, a small island in the North Sea. You might suppose it's impossible for me to appear here, but I'd venture it's mostly just not probable. See, as it is, Robin is trying to fly to Helgoland as we speak, from the south of Spain, a journey more improbable than my own. I read somewhere that robins use quantum entanglement to navigate, and quantum mechanics started here on Helgoland. Isn't that a funny coincidence? Well, I'd love to find this robin, and I'm also keen on understanding how it uses this weird science to migrate. As they say, if you ever need to find a bird watcher. We'll call this one Jeff. Everyone who comes to Helgoland is trying to find something. Oh, you're not ready yet. There you go. Jeff is looking for birds, of course, but in particular, he'd like to see a robin. A common bird in the UK where he lives, but most robins in the UK are homebodies, only traveling a couple miles a year. And robins don't live on Helgoland, so if you see one there, you know it's a long-haul traveler, one of the daring few to make it to this windswept rock. With hardly a tree to its name, legend says it's free of pollen. A young physicist came here in 1925 to cure his hay fever. It was a visit that would change science forever. But hold on the physics for now. It will come back later. In the spring, as songbirds cross the North Sea, facing unthinkable odds, Helgoland is the only safe place for rest. Birds from all over the world have ended up on this tiny island. Jeff is hoping one of these birds could be a robin, but to get here from Spain, ours will need to cover over 1,000 miles. Jeff is here in May. He thought he timed his arrival perfectly with the peak of spring migration. There's just one thing. Nothing about migration is ever certain. The next day, Jeff thought he'd be surrounded by thousands of birds. Our birder has made it to the island, but the songbirds haven't, yet. The weather in the North Sea is notorious. Sometimes the weather prevents the birds from arriving, and other times, storms bring the birds to the island. I wonder where our robin is now. Smells like France. Good progress. Robins fly alone. Long-distance migrants are often female. She still has hundreds of miles to go. You have some questions. I get it. I do as well. We're both a bit uncertain. That feeling, uncertainty, it led to a great discovery here, possibly on this exact spot. And in the absence of birds, Jeff is starting to learn other things about this mysterious island. Everyone who comes to Helgoland is trying to find something. In 1925, a young physicist named Werner Heisenberg arrived on the island. By day, he wandered the lonely shores and memorized poetry. By night, he sat awake, pondering a question. After several sleepless nights wrestling math equations, something changed. It felt like the earth fell out from beneath him. At 3 a.m., he waited for the sun to rise over the North Sea. Moments before, he'd had a revelation. It was an idea that would challenge our concept of reality. In 1925, this was our model of the atom. You've seen it before, the Bohr model. A tiny solar system. But of course, electrons aren't planets, and something they did confounded everyone. Did you see it? Jumped orbitals. There it is again, a quantum jump, proposed by Niels Bohr, building on the work of Max Planck and Albert Einstein. Bohr knew that electrons must make transitions from one quantum state to another, but he didn't know how or why they did this. He gave the problem to 23-year-old Werner Heisenberg. The young physicist dove headlong into the question. There was just one issue. His seasonal allergies were so bad it looked like he'd been in a boxing match. Achoo! He was trying to find relief. Rumors said Helgoland was free of pollen. This might be the only place he could go to think clearly. On Helgoland, his allergies evaporated, but the question now burned stronger than ever. It didn't make any sense. It seemed random. Every theory led to a dead end. One night, he decided to throw out the question. The how or the why, maybe they didn't matter. He focused on what could be observed. He set out to simply describe the observables. In this case, light. But this simple discovery, a way to describe the electron's behavior, would change everything, maybe even our understanding of reality. Heisenberg's work made uncertainty mathematically fundamental to how we see the world. For the northern Gannet, reality has always been uncertain. The Gannet lives in a liminal world, a seam running through cold air and a frigid sea, a flying knife thrown in a game of chance. There are different ways of seeing a Gannet. You could see them as a colony, a single, cacophonous organism. Over 1,000 Gannets nest on Helgoland each year. They form a wave of feather and sound, until our view collapses and we observe just one. You see the Gannet now as an individual, a lone specter on the north wind, a lord of hostile climes. With its serrated bill, it hunts and destroys. But it also loves. The same weapon used to skewer herring affirms a heartfelt bond. Now we see the Gannet as a pair. Every year, they return from distant solitude to find each other, often for the rest of their lives, to raise young together. Distance does not diminish their connection. The Gannet manifests in each of these states, collapsing uncertainty for just a moment, until, once again, disappearing into the wind of the North Sea. Perhaps one day they will all be gone, but not today. It's been a week, and still no sign of songbird migration. And I haven't seen any sign of our robin. I hope she's doing okay. A clear night to navigate. It's thought the robin looks for the movement of constellations to find the North Star, which stays still in the north. I hope this weather holds. Maybe instead of just waiting and watching, it's time to seek a better understanding of what the birds are going through. Jeff decided to seek out legendary birder and researcher Johann Dierschke.
My name is Jochen. I'm living on Helgoland since 10 years and I'm running the Helgoland Bird Observatory, which is the second oldest bird observatory of the world. And for me, it's the perfect place to work and the perfect place to live.
Before bird ringing, where did people think birds went during the seasons that they were gone?
It was often doubted till the 19th century that birds migrate at all. So if they disappear in winter, they some kind of dig themselves in the ground of lakes or in tree holes and so on. So I guess on Helgoland they were much cleverer because here it's just so obvious that they must migrate because you have these big concentrations of migrating birds flying over all day. Bird migration was actually proven by a white stork which had an arrow from Africa in the neck. So it was injured but could still fly and still migrate. That was actually taken as the proof that they really migrate to Africa. Golden oriole calling, I think. Yeah.
Golden oriole?
It's probably sitting somewhere there in these bushes. Can't see it.
It's shy.
Here in Heisenberg we use a special method to catch birds.
It's called the Helgoland trap.
It was developed here about 100 years ago, and we drive the birds with several people running through the good habitat and driving them into the end of the trap. It is very useful for catching large numbers of birds once you're able to concentrate them in a certain area, and then we can take them out and ring them, measure them, and release them.
If you put a small band around a bird's leg when you catch it, the next person who catches it, anywhere in the world, will know where it's been. This is one of the ways that we know that robins can fly to Helgoland from places like Spain. It's also good to collect a few measurements while you have it.
59,5. 7,9.
But no robins showed up today. Why would anyone spend days on end trying to see a European robin? It's a common bird. It's everywhere. Well, I'd say it's a bit like seeing a jazz musician walk past you on the street versus seeing them praying to the modal gods on stage with their trumpet. Seeing a robin here is seeing it at the moment of truth, at the height of its jeopardy, but at the height of its power. You dig? Uncertainty can mean disappointment, but the way forward is often uncertain. This was the case almost 100 years ago when Heisenberg's ideas formed the seed of a storm that swept the physics world. 1927, Brussels, the 5th Solvay Conference. 2 years after Heisenberg returned from Helgoland, the new quantum mechanics had divided the most prominent minds of the era. At the heart of the controversy, Heisenberg. Werner had taken his Helgoland epiphany to mentor Max Born. With others, they pioneered matrix mechanics, the foundation of modern quantum theory. Niels Bohr realized he would have to throw out his own model of the atom, but he was happy to do it, and he became a leader in the new school of thought. Erwin Schrödinger modeled the findings into a wave function, allowing simpler use in predictions. His cat didn't make the photo. Or did it? No one doubted the brilliance of the new conclusions. It was their strangeness that caused issue. One side, championed by Albert Einstein, argued the theory was just incomplete. Something was missing. On the other, Niels Bohr drove the idea that it was complete, it was just weird. In its simplest form, Heisenberg's idea meant that in a quantum state, a particle's behavior was best described by probability. Instead of sitting in a singular position, it made more sense to think of an electron as occupying a wave of probability, a cloud where it could potentially exist. But as soon as you observe the electron, the probability wave collapses, its position becomes known. A dance between the certain and the uncertain. It would take several years for Einstein's concerns to crystallize. He was haunted by spooky action at a distance, where an observation in one place had an immediate effect elsewhere. A relationship that seemed to violate the universal speed limit, the speed of light. This might be evident during a strange phenomenon called entanglement. I have something to admit. Although I'm starting to like this beach, I believe you've been observing me all over the island, and you might have guessed it as well. Everyone comes to Helgoland to find something. I think I came here to find myself, which is convenient because we'll need two of me before this is all over. Do you feel it? As time runs out for both Jeff and the Robin, there's suddenly a change in the air. If a storm happens to hit a migratory path during spring migration, it's called storm fallout. All the birds flying over Helgoland begin to fall out of the sky and seek refuge on the small island until the storm passes. Wait, that's actually something crazy. It's a red-footed falcon, blown way off course. Jeff had never seen one before. In birding parlance, that's called a lifer bird. Speaking of, a honey buzzard. Although the local crows didn't like it as much as Jeff did. But there's one bird that's conspicuously absent. It's the one bird that we wanted to see most. I can't help but wonder. Light is fading for our small traveler. As the sun and stars are blocked by the storm, I worry there's little chance of her clearing the North Sea. There is a small hope left. She still needs light, but not much. Just a few photons should do. The moonlight through the clouds could be enough. There's a photon. Follow it in. The photon is on a collision course with a strange chemical called cryptochrome found in the robin's eye. It will form a quantum entangled pair of particles when it hits. Entanglement. Some say Einstein was wrong about it, but as is often the case, if he was wrong in the right ways. When Einstein and two colleagues, Podolsky and Rosen, suggested entanglement, it was a critique of quantum mechanics, an example of something that shouldn't exist if we were describing reality correctly. They theorized that a pair of particles could enter a state where measuring one might affect the other, even over a long distance. Almost as if the particles could communicate with each other instantaneously. This seemed to violate relativity. The issue is when we observe or measure a particle in a quantum state. The particle could inhabit multiple states simultaneously before being measured, but only one when the wave of probability collapses. A superposition is when a particle inhabits multiple states simultaneously. Say I'm a particle. It's probable that I could be here, or I could be over here. But until you observe me in one spot or the other, it makes more sense to say I occupy both spots. In fact, many experiments confirm that I really do. Physicists usually measure a property called angular momentum, but for us, let's just say particles can be black or white. What's this? That's an elementary particle. And now, let's entangle our particles. When in a superposition, they're both black and white. But if we observe one to be black, then we know that the other must be white. You might say that the color is just hidden from us until we observe it. That's what Einstein argued. but experiments suggest this isn't the case. They truly are correlated in mysterious ways. It's theorized that the entangled particles briefly become sensitive to Earth's magnetic field, enough that maybe the robin can orient itself, almost as if it had an internal compass. When the cryptochrome is activated and the electrons are entangled, they're affected by delicate variations in Earth's magnetic field. The electrons could enter a signaling state where a domino effect might carry the message all the way from the smallest pieces of matter up to something the robin can actually experience. We don't know how the robin perceives these directions. One idea is that it's visual. It might actually see a navigational cue of some kind. Strange that at the root of all of this, the ideas that caused so much uncertainty are what give the robin a modicum of certainty on such an uncertain path. Isn't that a funny coincidence? Will it be enough? Jeff heard that a few birds had blown in the day after the storm. It's time for one last check of the Helgoland trap. Could it be? I'm glad you made it, small traveler. Everyone comes to Helgoland to find something. I think I've found what I was looking for. In fact, I'm absolutely uncertain